5.4 notes, Algebra 2. Okay, so for this lesson, simplifying expressions that involve complex numbers. Okay, a complex number has both a real part and an imaginary part to it. Okay, that's why it's complex. Now, imaginary units, the reason they came up with this, okay, up to this point, you haven't been able to take the square root of a negative number. Okay, this is a system of numbers that mathematicians created so we can deal with situations like that. Okay, so the thing that we need to remember now is, okay, I, which is what we use to represent an imaginary number, is equal to the square root of -1. Now, when you solve square roots, okay, in order to get rid of a square root, we square. Okay, so in this case, I squared is equal to -1. That is the key part we need to remember here. Okay, that's how we're going to simplify our imaginary parts when we get to quotients, when we simplify complex quotients. Okay, so write the expression as a complex number in standard form. When we are writing something in standard form, the real part comes first, followed by the imaginary. Now, when we are adding and subtracting these, it's just like if we were to use a variable. Okay, so imagine like that's a -1 plus 2x plus 3 plus 3x. Okay, you're going to combine your reals and then you will combine your imaginaries. Okay, now when you're doing this, be careful, especially when we get to subtracting, because you remember you are taking that first complex number plus that whole second complex number. So in this case, -1 plus 3, which will give us 2. Okay, and then we got 2i plus 3i to give us 5i. Okay, so when it comes to adding, that's pretty easy. It's just real plus real, imaginary plus imaginary. Now, when we get to the subtracting, okay, we got to be a little more careful when we're doing these, okay, because of the subtracting. So the real part of this one is pretty easy. 2 minus 3, we get -1. Okay, but then when it comes to the imaginary, we got -3 minus -7. So -3i minus -7i. Okay, so really we're doing -3i plus 7i to give us a total of 4i. Okay, I will see a lot of people give me -10i in that case. You're subtracting a negative, so we are really adding. Okay, so going on to the next one, we got our i's, our imaginaries, and then we got our reals. Okay, so again, we are subtracting that whole second complex, and again, when we're in standard form, we need to do real, then the imaginary. So in this case, -3 plus 2, we will get -1. And then for our imaginaries, 2i minus I, so let's write that out, 2i minus I minus 3i, because we're adding the -3i. So there we get -2i, so -1 minus 2i in that case. So when you're doing that, in standard form, real, then imaginary, and make sure you are being careful with the signs. All right, multiplying just like we do with just a variable, okay? We're going to distribute, in this case, so then we're going to get -3i plus, minus I squared. I times I, just like x times x is x squared, I times I is I squared. Now, this is where we need to remember I squared is equal to -1. Okay, so in this case, we got -3i minus -1, which will be -3i plus 1, and then finally put it into standard form with the real part first, 1 minus 3i. Okay, so now a complex times a complex. Above we just had an imaginary times a complex number. Here, FOIL. Okay, so 2 times -6, we get that -12. 2 times -2i minus 4i. 3i times -6 minus 18i. And then finally, 3i times -2i, so -6i squared. Okay, from there we need to simplify. Okay, first what I'm going to do is going to combine those i's. So I got negative 12 minus 22i. And then I'm going to replace that I squared with negative 1. So then we got negative 12 minus 22i plus 6. Combining like terms, we get negative 6 minus 22i. So nothing really new. I mean, other than the I squared, replacing I squared with negative 1. Okay, same concept as when we just have variables. All right, so here, again, FOIL. Okay, so 1 times 1, we get 1. 1 times negative 2i minus 2i. 2i times 1 plus 2i. And then 2i times negative 2i, we get minus 4i squared. Okay, one thing you're going to notice, we get the same thing there. They cancel each other out. So 1 minus 4i squared, which will equal 1 minus 4 times negative 1, replacing I squared with that. So 1 plus 4, or 5. Okay. This one right here is very important, actually, because this is the concept we're going to need to know to help us with quotients, okay, and division. Okay, if you notice, the only difference between these two complex numbers is the sign in the middle. Okay, 1 plus 2i and 1 minus 2i. Okay, these two complex numbers are considered conjugates. And what you notice if you multiply conjugates is that you will get a whole number. Okay, that is an idea that we need to have when we move to quotients. Okay, because when we are in standard form for a quotient, there will be no imaginary numbers in the bottom. Okay, so that's the whole goal of this. We need to get rid of that I in the denominator. Okay, so what we're going to do is we're going to multiply by that conjugate of the denominator, which in this case is 1 minus I. So we got 2 minus 7i over 1 plus I. In order to get rid of the imaginary in the bottom, again, multiply by the conjugate of that denominator. Now, whenever we multiply a fraction like this, you need to make sure to multiply both top and bottom. Okay? Because when I do that, 1 minus I over 1 minus I, that is just 1. Okay? So we are really just changing the way it looks. We're not changing the value of it. Okay? So go ahead and we're simplifying this here. So we're going to take the top and multiply the top. We're going to end up with 2 minus 2i minus 7i plus 7i squared over 1 minus I plus I minus I squared. Okay, so again, that should happen. That should just cancel each other out with just the i's when we multiply by that conjugate. So simplifying that numerator, 2 minus 9i plus 7 times negative 1, replacing that I squared with negative 1 over 1 minus negative 1. So 2 minus 9i minus 7 over 2. And finally, combining those in the numerator, 2 minus 7 will give me negative 5 over 2. There's that quotient simplified into standard form. Now, really, to have in standard form, we should have that real and then the imaginary. So we should actually write this as negative 5 halves minus 9i over 2. Okay, then I'm separating my real and my imaginary. So technically that is standard form. All you're doing is taking negative 5 halves minus that 9i over 2. Okay, so doing another quotient. Okay, we're going to multiply again by the conjugate, which in this case would be 2 plus I root 5. I have to do it to both top and bottom. Okay, a little more complicated. Now we're going to get those square roots in there, but we can deal with that. Okay, so, foiling out, 6 plus 3i root 5 plus 2i root 5, and then finally plus 5i squared. Okay, because when you multiply two square root of 5 times square root of 5, that's square root of 25, which simplifies that 5. Now we still have that I times I. Okay, multiplying that denominator now, we're going to get 4 plus 2i root 5 minus 2i root 5 minus 5i squared. Okay, those should cancel out again. So, simplifying that numerator now. We're going to get 6. Okay, 3i plus 2i, that's going to give us that 5i. And we're still going to have that root 5 plus 5 times negative 1 over 4 minus 5 times negative 1. So, 6 plus that 5i root 5 minus 5 over 4 plus 5, because we're going to subtract a negative 5, so plus 5. And combining like terms again finally. 1 plus 5i root 5 over 9. Now, again, we are not technically in standard form yet. Separating those. So 1/9 plus 5i root 5 over 9. Okay, we'll leave that one. But just remember, everything when we're doing complex numbers, real, then the imaginary. And if you have it like this, make sure to separate the two into its real part and its imaginary part. Just real quick, in this case, you would multiply by 1 plus 2i. Again, that's the conjugate of the denominator. Okay, your homework worksheet 1 through 15 on the 5.4 worksheet. So just 1 through 15 in that case, and then the others will be, well, that's all it is. So 5.4 worksheet, that is your homework. Other than that, have a good day.